Hunga Tonga Volcano eruption on January 15, 2022. The Hunga Hapai volcano in the nation of Tonga was primed to blow. The previous day, a landslide had occurred on its ash-covered plateau, cutting the island in two and causing seawater to seep into the underlying magma conduit. This water was subsequently heated by the adjacent magma, causing it to flash to steam. Since steam takes up a larger space than the same volume of water, it caused an immense amount of pressure to build. Then, at 4:28 p.m. local time, the volcano catastrophically exploded in what was equivalent in energy to a 6-megaton blast of TNT. What had just occurred was the single largest volcanic eruption on the planet since 2011. Since it is now a month later, scientists know a bit more about the eruption which occurred that day, which at first presented a number of unresolved questions. Halfway into space, for example, we initially believed that the eruption plume only reached 35 kilometers or 115,000 feet in height. However, NASA later released a statement which showed that the eruption column had reached even further to an impressive height of 58 kilometers or 190,000 feet in height, which is more than halfway into space. This means that the eruption plume surpassed a theoretical limit of 50 kilometers in height which no prior eruption column had done, passing into the mesosphere. Typically, the lower boundary of this atmospheric layer largely kills any upwards mobility a plume has, causing it to disperse and maxing out the cloud's height. Thus, it was quite a surprise to see the plume temporarily reach a height of 58 kilometers, as this even surpasses the eruption plume height of the last Toba supereruption. You heard that correctly, the eruption column was taller than one produced by a supervolcano. Why the eruption plume was so tall? So, why was this plume height able to rise into the mesosphere, defying all expectations? The answer to this involves several factors,